So, in this lesson, we're going to be doing 2.2. So, this lesson is about actually graphing motion graphs, right? So, I'm going to be introducing you guys to two different type of motion graphs in this video. And the first type of motion graph is called a position time graph. A position time graph is a graph that measures the position of an object over time. Right? So it measures where you go at what time and when you go to it. So let's go to the simulation that I linked here. Right? So let's say we have this man at 0 meters, right? At a position of 0 meters. And let's say we move him. So we move him all the way. And now we're at a position of 5 meters. Right? So this is what you see. Right? You see someone moving to a position of 5 meters on the y-axis. And now he's standing there, and this is what the graph would look like, right? It measures position. And now I travel back to 0, and maybe go to like -5 meters. And so this is what you would see. So it measures your position over time. It measures where you go over time. Reset this. On the other hand, a velocity time graph, measures what your velocity is over time. So the y-axis is your velocity and the x-axis is your time. Well, what does that look like? Right? So again, let's have this guy right here. Let's actually have him move to the right. So let's have him move slowly. And now move fast. Stopping. Move slower. Move fast again. Right? And now let's move in the negative direction. So now we have a negative velocity. So we're getting faster now, right? So this graph measures how fast you are. Right now, we have a velocity of 0 because I stopped him. So you see that the red line is at 0 on the y-axis, right? So you see this arrow here, right? We're now on the y-axis. Actually, reset this. We're going to do this again, right? So this guy has a non-zero velocity now. So speeding up. Now he's slowing down, right? Now he's going the opposite direction. So now he's going in the opposite direction at that velocity. And now he's standing still, right? Because now he's stopped. And so our velocity here is 0. Okay. So you've been introduced to the two graphs now. Let's actually plot them, right? So let's first map an object at rest. Let's figure out what an object at rest looks like. Let me get my cutting tool. So just paste this. So if an object is at rest, what's your velocity? Right? There's something we can assume here. We can assume that our velocity is 0 if our object is at rest, right? We're not moving. So let's start with our velocity time graph first. If our velocity is 0, where will we plot our point? Again, and how do we identify coordinates? We do x, y, right? We do the x coordinate first, y coordinate second. The y coordinate is that, x coordinate is this. So we're going to plot it at 0, 0. Let's use a different color. Green. Maybe that's too punishing for the eyes. That's pretty punishing for the eyes. Orange. Fine. So 0, 0 is where we're going to plot our point, right? Because our velocity is 0. So we're going to start at 0 meters per second. If our object is still going to be staying at rest, then at 1 second, what will your velocity be? If your velocity hasn't changed, well, your velocity is still 0. What about 2 seconds? Where's our plot going to be? Where are we going to plot our point if velocity is still 0? We're going to plot it at 2, 0, 2, 0, and so on and so forth, right? 3, 0, 4, 0, because our velocity doesn't change. So now we'll look at our position time graph. So let's say, I say we start at a position of 5 meters, right? Because that's what this says. So let's say we start at a position of 5 meters. That's where we start. And if you guys can't visualize that, right? If you guys can't visualize that, so this is 0 meters, right? So this is 1. I'm just imagining it's 2, 3, 4, 5. So now we're at a position of 5 meters, right? I have a stick figure over here. And if our object is at rest and our velocity is 0, and we're not changing our position, where are we going to be at 1 second if our object is at rest? Well, we're still going to be at a position of 5. Right? So our plot is over here. We plot our dot over here. And at 2 seconds, if our object is still at rest, well, we're just going to plot it over here. All right. Over here, and then again, so on and so forth, right? Our object is not moving. So that's what the graph is going to look like. Hopefully you're copying this down on your notes. I'm going to erase all of this in just a second. You can pause it, right? All right, let's move on. Now, an object at constant velocity in the positive direction. And what is that going to look like? Yeah, that means, and we're going to start at 0. Start at 0, and we're going to move this way. So constant velocity, what does that look like? Let's say our velocity is 1 meters per second. Right? Let's say our velocity is 1 meters per second, so we're going to put our dot there. What does it mean to be at constant velocity? Well, constant means you're staying the same, right? You're unchanging, staying the same. Staying the same. So your velocity is not going to change. If you have a my voice cracked there. If you have a constant velocity, what is your velocity at 1 second if your velocity is 1 meters per second? Well, if it's constant, it doesn't change, which means you still have a velocity of 1 meters per second. You still have a velocity of 1 meters per second the second, as well as the third. And so we're going to move this way, right? So we're going to have a straight line. Now let's do our position time graph. Let's plot what it means on our position time graph. And again, we're starting at a position of 0. Starting at a position of 0. We covered this in 2.1, but what does it mean to have a velocity of 1 meters per second? Well, it means your velocity changes. Rather, you travel 1 meter each second, right? Because that's what 1 meters per second means. Every second you move 1 meter, 1 meter per second. So if your position changes by 1 meter each second, and you start at 0, where will you be at 1 second? Well, you'll be here. If velocity is 1 meters per second, where will you be at 2 seconds? You moved 1 more meter. At 3 seconds, you're moving another meter. And so it's going to look something like this. So this is a position time graph of an object traveling at constant velocity. Let's do this one. Let's do 2c. Let's do an object traveling at negative, in the negative direction at constant velocity. So negative direction means you're starting over here, right? Or anywhere really. And you're going to the left or whatever opposite direction of positive is. So here's the thing. Let's start with the velocity time graph first. So let's say our velocity is negative 1 meters per second. So we're going to start here. And we know that it's a constant velocity, so our velocity doesn't change. It's going to be a negative 1, so our velocity doesn't change, which means our plot stays the same. So it's just a straight line on a velocity time graph, right? Because your velocity will always be negative 1 over time. So let's do the graph on this side. So it says assume the position to be 5 meters. Your initial position is going to be 5 meters. And so what does this velocity mean? Right? What does having a velocity of negative 1 meters per second mean? Right? So every second, to reiterate, right, meters per second. So every second you move, you travel negative 1 meter. That's what this velocity is saying, right? This velocity is saying that if your velocity is negative 1 meters per second, every second you travel negative 1 meters. So 5 to 4, right? So if our initial position is 5 and we travel negative 1 meter, we go from 5 to 4. And every second we travel negative 1 meter, well, we're going to go from 4 to 3, and then 3 to 2, and then 2 to 1, and then 1 to 0. Right? And this is what our line is going to look like, the constant velocity in the negative direction. And just because you crossed over the x-axis doesn't mean you stopped, right? Because you're still traveling at a constant velocity. It just means we're now moving in the negative direction. So now we're at negative 5, right? And then negative 10 and so on and so forth. All right. So do this slide. Slope of a PT graph. So in math, you've learned that, well, slope, how to calculate slope, right? So in math, I think you learned it like this, right? So y2 minus y1 and x2 minus x1. We're going to do something really similar. And we're going to learn it like this. I'm going to teach you it like this. So we're going to do slope is equal to delta y over delta x. And this delta means change in. So it means change in y, change in x. And that's what the delta means. Right? That's what the delta means. Right? And so it's basically how much your y is changing, which is essentially y2 minus y1. And so now the next question is, well, what is it on the y-axis for a position time graph? Well, is d, right? So d is displacement here. And the x-axis is time. Time is seconds, right? Meters. And so our slope is d over t. Right? Our slope is d over t. Now, our slope is d over t. And so there's a formula on our reference table that resembles this, right? It's actually the first formula. So v bar is equal to d over t, which is average speed or average velocity. So this is average velocity. So based on this, we can assume that, so slope on a PT graph, and a PT graph only, represents velocity. All right, so this is something you can assume. This is something you can assume. Did I skip a slide? I did skip a slide, but we'll come back to it later. We'll come back to it later. So now we're gonna do some practice questions. So slope of a PT graph. All right. So slope of a PT graph, calculate the velocity between 0 and 2 seconds. So again, you're trying to figure out what the slope is. So the slope between 0 and 2 seconds, what is your change in y over your change in x? So your change in y here, if you're going from 0 to 2 seconds, if you're going from 0 to 2 seconds, you start here and here. Well, how much did your y change? Well, my y changed by 8. How much did your x change? From 0 to 2, your x changed by 2. Right, so your speed, your velocity is 4 meters per second. Calculate the velocity between 2 and 4 seconds. Right, so we're going to do slope again. So the slope, what's my change in y over change in x? My change in y, if I begin at 8 here, I end at 8. Right, I begin at 8, I end at 8. My change in y is 0. Again, x is from 2 to 4. I change by 2, right? Because that's how much my x changes. And so my slope here is 0. We're going to do the same thing here for question number 3. What's my change in y from 4 seconds to 8 seconds? Right, so my initial position was 8 meters. Final position, 0 meters. I'm going down. That's negative 8. So that's my change in y, right? My y changed by negative 8. And my x changed from 4 to 8. It changed by 4. So my velocity from 4 to 8 seconds is negative 2. Calculate the velocity between 0 and 8 seconds. What's your change in y from 0 to 8 seconds? If I started at a position of 0, I ended at a position of 0. So start at 0, end at 0. Well, then my change in y is 0. And then it doesn't matter what your change in x is. 0 divided by anything is 0. So you get 0 here. Okay, let's go back. Let's go back to the previous slide. Let's go back to this one. Calculate the distance traveled between 0 and 2 seconds. So it's better to... So I would draw a diagram to help you picture what's going on here. So again, your y-axis is your position. Your y-axis is your position. So this is telling you in 2 seconds, you went from a position of 0, so you walked, or you ran, or you traveled, and you traveled to a position of 8 meters in the first 2 seconds, right? Because that's what this is saying. You went from 0 to 8 in 2 seconds, so you traveled 8 meters. And the next question says, calculate the distance between 2 and 4 seconds. Well, if you start at 8, you end at 8 meters. Right? You start at 8 meters, end at 8 meters. Did you really move anywhere from 2 to 4 seconds? No. You didn't travel anywhere. You're at rest, right? You didn't move. Like this line right here tells you that you didn't move. You stayed at 8 meters. The next question says calculate the distance between travel between 0 and 8 seconds. So from 2 to 4 seconds, you didn't move. But from 4 to 8 seconds, you went from 8 meters all the way back to 0. So what this looks like on a diagram, you went from 8 meters here, right? You went from 8 meters and traveled all the way back to your starting position. So the first 2 seconds, you traveled 8 meters. The last 4 seconds, you traveled another 8 meters. So the total distance you travel in 8 seconds is 16 meters. You went 8 meters this way, then 8 meters back. That's what this 8 right here means. The next question says calculate the displacement in 8 seconds. Again, displacement is how far you are from your initial position, or your final position minus initial position. Right, final minus initial position. Right, that's what displacement is, how far you are from your initial. So your final position here is 8. I'm sorry. Your final position here is 0. Right? Final position here is 0. You end at 0. Your initial position, you start at 0. And you get 0. Alright, that's going to be this lesson.